Good afternoon, everyone. Today we're going to do a quick example of using long division to figure out if x minus 3 is a binomial factor of our cubic function x cubed minus 4x squared plus 7 or not. Okay? So again, we're going to use long division, so we're going to set it up the same way we always have for many years now. So we'll have our divisor, x minus 3, out to the left, and our dividend, x cubed minus 4x squared plus 7 inside. Now, you might notice at first glance that there's no x term, right? That's just the way that it is. Now, if it helps you organize your process, if it's just nice for you to have things be aligned, feel free to sub in that 0x in between the x squared and the constant term, but it's not necessary. It's not going to change anything. It's not going to impede you. It's just going to be one little other thing you're going to have to deal with. It's not going to change the results. It's going to be the exact same thing in the end, so it's totally up to you. Personally, I don't bother, but again, you do have that option, right? So now let's go ahead and get started. So the first step is x times what gives us x cubed, or in another way, x cubed divided by x produces what? Well, that's a quotient of x squared, and so that's what goes up top in our quotient of x. So now we multiply through the same way we always have with long division. So x squared times x is x cubed. And once again, it's always the leading term that leads the way. It kind of dictates the entire process. That x term, that leading term dictates the entire process. That minus 3, that secondary term, is just along for the ride. You don't really have to worry about it at all. It just kind of does its thing and goes through the iterative process, okay? So x squared times that negative 3 means negative 3x squared, and now we subtract this entire thing. So the x cubes obviously cancel out, that's how we made it to be. And now negative 4x squared minus negative 3x squared, we're combining two negatives put together, act like an addition, and so negative 4x squared plus 3x squared leaves us with one negative x squared. And now, again, if you had the plus 0x, you could bring that down. You would have the same result in the end. I'm just going to bring down the plus 7. And now we're going to repeat the process. Okay, just an iteration again. So x times what becomes negative x squared, or if you want to think of it as division, negative x squared divided by x is, of course, negative x. And so that's the second piece of our quotient up top. Now we multiply through. Negative x times x is that negative x squared, of course. That should be the case. That's how we made it to be. Now, negative x again multiplies that negative 3. Negative x, negative 3 plus 3x. And we subtract all of that. And so the negative x squares can easily go away. Now, I'm going to be careful how I write this because we have one more step to go through. So I'm going to write negative 3x first. And that plus 7 on top, although it's a little bit counterintuitive because the 7's on top, I'm going to write after. Now, it wouldn't make a difference if you did it the other way. It's simply maybe a bit more aesthetically comfortable to have it written this way, because this is typically how we write linear functions. Because now we can ask ourselves, okay, are we done? Well, x times what becomes negative 3x. That's simple enough, right? That's negative 3. And so we do have one more part to our quotient up there. Negative 3 times x does give us that negative 3x. And now, finally, then negative 3 times that negative 3 produces plus 9. We can subtract all this, and so the negative 3x's cancel each other out. 7 minus 9 leaves us with negative 2, and that is our remainder. And of course, negative 2 is not equal to 0. And so, answering the question, is x minus 3 a factor of this polynomial, this cubic polynomial? Well, the answer is no, because our remainder, negative 2, is not equal to 0. So, not a factor. Exclamation mark, sad face, because of course we want it to be a factor. And there we have it. So this would be considered our quotient. This would be formally referred to as q of x. For those of you that are studying these sections. And the remainder of non-0 means that we don't have a factor in this example. Okay? I hope that helps. If you guys have any questions, comments, suggestions, please feel free to leave me a message. Let me know anything else I can do to help you guys out, and have a great day.